Assalamualaikum warahmatullahi wabarakatuh and a very good day. I am Binti Mohd Idris from College Jenis Insan, University Science Islam Malaysia. So for this iMake 2021, I would like to present on our innovation project with title Low Cost As-Synthesized Carbon Nanotubes as Potential Electromagnetic Absorbing Materials. Okay, the outline of this presentation is first description and explanation of the product. Next is the problem statement, impact, novelty, and achievement of the product. So what we are going to do is that we try to introduce from waste to wealth, whereby we are using mill scale from the industrial waste, and we try to convert it, we try to use it to produce something which is new and not being done previously. So that is why we try to convert from waste to wealth, and at the same time it is for our own health, whereby we try to protect ourselves from the electromagnetic interference radiation pollution. So the description of the product is that we are using raw mill scale from the industrial waste, and it is actually in flake form, and we are using high energy ball milling, which is we try to crush the flake into nanoparticle size or nanopowder, and then we are using it as a catalyst to grow carbon nanotubes or carbon nanofibers, and then we try to mix it with polymer. Okay, so this is the example of the FISM or the micrograph of the sample after being synthesized by using chemical vapor deposition, which is to produce the carbon nanotubes. So we can see that there is actually a mixture of twisted fiber, spiral-like, straight-like, and net-like fiber. So all of this is actually helps in absorbing the electromagnetic wave, which is we can have multiple reflection of electromagnetic wave in the sample. So finally, we characterize, or we are using vector network analyzer for measurement to know what is the reflection loss of the sample. So this is the example of the sample that we have done, the prototype, the earlier prototype. So we do it in square shape, okay, and it is actually flexible. We can see here it is flexible. So for problem statement, almost all people around the world now live within range of a mobile cellular network signal, with 90% living within range of a 3G quality or higher network. So right now is a pandemic COVID-19, so everything is online, meeting is online, and having class is online. So there are lots of gadget or laptop being used that contributes towards more electromagnetic interference pollution. So the accelerating growth of higher frequency devices creates more electromagnetic interference pollution that cause disturbances on the equipment and systems for medical, industrial, commercial, and military applications. Furthermore, continuously exposed to electromagnetic radiation for a considerable period of time is also potentially harmful to biological systems. So in Sustainable Development Goals 3, which to ensure healthy lives and promote well-being for all at all ages, it is important in reducing the environmental risk from the harmful electromagnetic interference. Thus, many research interests focus on producing electromagnetic absorbing materials that are effective in attenuating these unwanted electromagnetic energies. So for the impact, the electromagnetic interference which can harm smartphones, tablets, chips, drones, wearables, and even aircraft and human health is increasing with the explosive proliferation of devices that generate heat. These electromagnetic absorbing materials have important social and economic benefits, and the market for EM blocking solutions which employ conductive or magnetic materials is expected to surpass 7 billion by 2022. So furthermore, the underlying science of the electromagnetic absorbing mechanism and the knowledge can be transferred to the local industries, therefore can increase the capabilities of Malaysian industries into the manufacturing of high-end products. So for the novelty, conceptualize the mechanism which contributes to the absorption or loss mechanism, reveals the extrinsic and intrinsic parts that contribute to multiple internal reflections, insight to the underlying science of the electromagnetic absorption mechanisms. The data obtained from this research is useful as a reference and guidance for the development of new and perfect electromagnetic absorbing materials in the future. So the hybrid nanocomposite produced is from waste, which is the mill scale, and the hybrid nanocomposite 3D printed honeycomb structure that will be produced helps in having multiple reflections in the sample. So what we try to do in this with the sample is that we try to produce thin, lightweight, and flexible. So lightweight and low cost hybrid nanocomposite 3D printed honeycomb structure absorbing the electromagnetic wave in a broad frequency range is useful for various applications. So this is the figure is an example of the electromagnetic absorbing material that we have used. For example, we can use it as a phone pouch, and then cap, casing, vest or apron, and watch. So this is the example for the military or armored vehicle, whereby we put our sample into one of the surface of the armored vehicle. So for the achievement of the product, so previously we have won Best Micrograph Award, okay, due to the field emission scanning electron microscope, the micrograph that we get. So first place award for 2 years in 2015 and 2016. So this is the Invention, Innovation and Design Exposition, IDEX 2020. So with the title Low Cost Micro-Absorbent Materials in Reducing Electromagnetic Wave Interference Pollution. So this is the latest award that we received. So we get Gold Award for this Innovation and Design Exposition. So next is for Materials Technology Challenge. So the title micro absorption performance of hybrid nanocomposite at high gigahertz frequency range. So you get Gold Award for this Materials Technology Challenge. So for this MTC 2019, we also won a Silver Award, and MTC is actually organized by UPM and organized by a Solid State Science and Technology Organization. So for this International Symposium on Advanced Materials and Nanotechnology, ISEN 2019, so we have won Silver Award. So for Malacca International Intellectual Exposition, MIEX 2019, we have won Bronze Award. And with the title Introduction Low Cost Waste Materials as Electromagnetic Wave Absorber at Gigahertz Frequency Range. So this is last time from Pameran Reka Cipta Penyelidikan dan Inovasi Malaysia, organized by UPM. So composition, formulation of high performance of EMI suppressor. So this is we got Silver Award. So we have patent file previously with the title of invention, method for producing lightweight absorbing material for electromagnetic radiation absorption, lightweight absorbing material, and spiral light carbon nanofiber associated thereof. So these are the grants received. Previously, long-term research grant scheme, which is LRGS, whereby we try to coat our sample at the surface of armored vehicles. And then the new grant is from Fundamental Research Grant Scheme, FRGS, which is in 2020, and USIM Racer Research Grant in 2020. Okay, we also publish as a chapter in book, which is in chapter 5, Recycling and Utilization of Mill Scale to Produce Current Smart Electromagnetic Absorbing Material. Okay, so the title of the book is Degradation of Inanimate Forms, which is under Innovation for Sustainability and Green Technology. Okay, so these are the publications and some of it, and there are also other publications related to this project. Okay, so this is one of the video recorded by my student, whereby we have won Gold Award in Index 2020. This is the latest award that we have won.
Main features of an electromagnetic absorbing materials are low cost, light in weight, thin in thickness, have high absorption ability, flexible, and eco-friendly. So, to analyze the performance of the mill scale, which is industrial waste and epoxy, as the electromagnetic absorbing material, electromagnetic radiation tester is used.
So this is a phone. This is electromagnetic radiation tester. So firstly we will test the phone without any cover. As we can see, the radiation value is high. Next, we test it with cover with the towel. As we can see, the radiation value is still high. Now we test it with our electromagnetic absorber that we propose. So as you can see, the radiation value is reduced and is low.
So this is the acknowledgement. That's all from me. Okay, thank you.